All right, welcome everyone. We're going to get started. Good morning, welcome to the Content Delivery Summit. My name is Dan Rayburn, I'm the conference chairman. Apologies with my voice a little this morning, it's just allergies. My voice will get better as the day goes on. I will be here all day. Happy to answer questions and do meetings with anybody who needs help. You'll see me running throughout the hallway here all day, managing both of our tracks and our sessions. But if you have questions at any time, please just stop me. I'm happy to hear about why you're here, what you want to learn from the show, any introductions you may want as well. That's part of my job here, is to play matchmaker all day, connect companies with attendees. So I do a lot of that. I'm going to make a couple quick announcements and we're going to jump right into our keynote this morning. I'd like to thank all the sponsors of our show that we've had today. You can see in the brochure we have a lot of companies that are supporting us, especially our platinum sponsor, Verizon Digital Media Services. In addition, we have lunch that will be served at 12:30. So it'll be boxed lunch out in the hallway, just outside here. You'll come back into this room. And that's being provided by ZenEdge. At 5:30, we have a reception downstairs. So if you walk into the front of the hotel and walk all the way to the back, there's a nice little place on the left called Urban Kitchen. That's where we're going to have our reception at 5:30. I do the last presentation of the day from 4:30 to 5:30 here in this room. So if you come to my presentation, I'll show you where that is afterwards. That presentation is, reception is being sponsored by Aspera, so thanks for that to them. Also, all the sessions today are being recorded, audio and video. We're not streaming anything live. We'll be streaming live tomorrow, Tuesday and Wednesday at the Streaming to E show. But everything across both tracks are all going to be archived. If you go to streamingmedia.com/videos, that's where you can see all of our archives for all of our past shows. We typically archive about 5 years worth of content. So if you want to see any content delivery sessions from last year, that's where you can go as well, streamingmedia.com/video. I was going to take a minute or two here. It's going to take a little bit longer, but my voice isn't great now, so I'll do it during my presentation. But I did want to take a minute or two to talk about just what we've seen in the industry over the last few years. It's amazing to stand here on stage and think about even 2 years ago what we were seeing in the content delivery space. Whether it was video, small objects, software downloads, applications, mobile content acceleration, it's amazing how quickly this industry moves, this facet of the overall industry moves. So we went from having CDN services that were pretty commoditized, where a lot of people were talking about just price, to where we're now talking about QoS. We're talking about QoE. We're talking about measuring services from a consumer standpoint, which obviously is very important. We also have a lot going on in terms of multi-CDNs. So customers who are using more than one CDN, and some services and platforms out there that allow them to shift between CDNs in real time based on performance. That's somewhat new to the industry as well. In addition, we have all the DIY, the do-it-yourself CDNs. We're starting to see some more of those as well. I'll talk about that during my presentation at 4:30. But it's amazing to see just how many vendors we now have in the ecosystem for delivering content. And one of the things I did with the show a couple years ago, which we'll continue to do, is it's not just about video. So 8 years ago, this show started, and 100% of everything we covered was how to deliver video on the internet. Whether we were talking last mile or caching, transparent caching, it was all about video. Today in the program, you'll see we're talking about security. We're talking about DDoS services, all the things that go along with DDoS. We're talking about mobile content acceleration. We're talking about a lot of different stacks in terms of the ecosystem. So great to see where the market is headed. I'm going to cover a lot of that in my presentation, talk about the competitive landscape. Also going to give out some market sizing numbers and some pricing on different services. But hopefully you see in the program where we're trying to progress with the show is really follow the industry in terms of the products and services that customers, whether it's broadcasters, MSOs, MVPDs, whoever it may be, are really looking for. So you'll see that over the next day in terms of both tracks. You'll see the types of content that we're now covering. So for the keynote this morning, excuse me, the way this is going to work is we're not going to run around with a mic for Q&A because it's a small enough room. So once he's done with the presentation, if you have a question, please just raise your hand. He'll repeat questions from the audience so everybody can hear them. And it's about a 30 to 35 minute presentation. There's some really good data in here. He's going to give out some numbers from Google as well, which is really nice. Appreciate Google being here. Google, from what I know, doesn't typically speak at many of these events, especially from the cloud side, so it's certainly good to have them represented. I'll let you go through your background. So with that, please welcome, I'm going to try and get this right this time, Leonidas.
Thank you.
Thank you.
Good morning, everybody. Can you hear me? Yes. Back there? Microphone works? Okay. So hi, I'm Leonidas. I'm an engineering director at Google. Been there for 11 years in the Boston office. And I'm in charge of what we call front-end network infrastructure. So that's the part of networking at Google that deals with user-facing traffic. So no matter what service you're accessing, whether it is a traditional Google service or a cloud service, typically you will go through a layer of distributed proxies that my team manages and runs. But today I'm here to talk to you about our media offering, in particular what we're doing with Google Cloud and media. So before actually going to the details of the technologies that we bring to bear on media, I want to discuss some trends that are probably known to all of you, but they're accelerating so much that it's worth revisiting them. First and foremost is that media consumption is becoming more a la carte. So consumers want to watch what they want to watch when they want to watch it. They don't want to sit in front of the TV with the linear programming. My kids actually think that the TV is only used for video games. They like whatever they want to consume as a passive consumer is usually on their tablet. And I think that trend is accelerating. If you look at the number of hours watched on other screens at this point, like YouTube, for instance, is more popular. More hours is being spent watching YouTube than any channel in the world. The next thing that's happening is that, as I said, the number of devices and screens that people are consuming content is proliferating. So people want to watch on the go. They want to watch at home. They want to do it sort of on their TV, their set-top box, their tablet, their mobile device. And the interesting thing is the industry is responding. I'm sure many of you have seen the AT&T commercials where if you're a customer of ours on, say, the TV side, we'll essentially flat rate everything that you're doing on the mobile side. You'll be able to watch the same shows regardless of where you're being located. The last trend that actually is happening is the volume of content that is being created is accelerating. If you look at the number of shows that exist today relative to the number of shows that we had 3 years ago, is double that, what we used to have. And if you look, and that's just the professionally created shows. If you look at sort of the smaller producers or even user-generated content, then the place has completely exploded. So YouTube, for instance, gets about 400 hours of new content uploaded every minute, and that is sort of giving a platform for people to express their creativity, and many of them are actually finding takers. There's a number of famous people, like say Justin Bieber, or many of the video game sort of presenters that have become household names through a platform like YouTube. So what we're doing in this space is we're trying to enable everybody, not just people using our internal platforms, but also people that want to use their own platforms to bring media, make it accessible to everybody through the use of Google Cloud. So cloud is actually a very big part of what Google does. It has always been a very big part of what Google does. If you think about it, when you think of Google, you think of the services that we offer. What is little known is that the largest engineering department at Google, probably by a factor of 3, is what we used to call technical infrastructure, and now we call cloud. So a little, less than half of all of our engineers are actually working on services that the rest of the company is using, to bring, the applications that you now use, like search and YouTube and Maps and Gmail. And now what we're doing is we're taking that infrastructure that we built for internal use and we're exposing it to our cloud customers. So if you look at the amount of investment that we are bringing, it's over the last 3 years we've invested $29 billion in cloud infrastructure. That includes data centers, that includes networking. That includes the software development that we're doing to bring these services to the market. We're serving over 1 billion unique IPs every day, and we have built a global network, the largest global private network in the world in terms of span and in terms of traffic handle. I have more data on that later. And we bring the highest reliability in the industry. We are building our products, with 5 nines reliability in mind, and this is the thing that we're trying to bring to the rest of the market. So To prove that this infrastructure is not something that we just built recently, here is a small reminder. So all of the services, search, Maps, Play, YouTube, Gmail, delivery of the Chrome browser, and sort of the Android market, and Android over-the-air updates are all running on the same infrastructure that the commercial version of Google Cloud runs on. So this is the thing that we're bringing to everyone, and we're very excited to be in this space. We think it has a lot of future, and we expect that the IT industry and the media industry and all of the industries that are making use of computing will eventually migrate a big part of what they do onto the cloud. So we have a fairly large number of external customers as well. I will mention a few names. Snapchat is probably the best known. All of their infrastructure runs exclusively on Google Cloud. They are one of the largest social networks around, probably the second largest, I think, after Facebook and its spin-offs. And they have developed everything from the beginning onto Google Cloud and continue to do so today. Some other names that you may have heard: NBC Universal, Autodesk, Univision. They're also customers of Google Cloud. So, in particular, when it comes to media, Google thinks this is a very important vertical. So, in addition to the horizontal technologies that we'll cover a little bit, we think that media deserves special attention and deserves specialized technologies and solutions that we have to bring. And this includes things from very early on in the production stage, like rendering and processing and workflow processes. So and then intelligence, personalization, monetization, and of course the more traditional technologies that have to do with delivery and playback technologies. So some of those are acquisitions like Zinc and Envato, and some of them are internal development that we're actually bringing to the market. So for the rest of this talk, I'm going to actually divide it into 3 parts. I'm going to talk a bit about the production side. What does Google Cloud bring into producing media? I'm going to talk about the personalization side, which I think is one of the most interesting areas, because consumers are going to want their media consumed the way they want to, rather than the way we traditionally delivered, which is the one-to-many approach, like same thing for pretty much everybody. And then finally, I'm going to talk about sort of the network and delivery aspect of it, and what Google has done in that space. So first, on the production side. Obviously, the most interesting thing here is how quickly can you bring compute to bear in your production infrastructure. So Jungle Book, which won the special effects Oscar for 2017, is one of the things that was developed on Google Cloud. It took 4 million CPU hours to actually do all the special effects, and if you had run this on a conventional cluster with a few hundred servers, we estimate it would have taken 41 years of compute time. This was actually completed with the power of Google Cloud in a little over 2 months. So you could do this thing by building it yourself, but it probably doesn't make an economic sense. You are not going to be in the business of actually rendering minute after minute, sort of those kinds of heavy-duty tasks. Google Cloud brings the scale that you need only when you need it. And with some of the offerings that we have, like say batch processing, if for instance you have a job that is very heavy on compute but does not have a real time constraint, it doesn't need to deliver something the next second. You look at the batch processing offerings that we have, and from an economic standpoint, they're an amazing deal. So if you are actually very interested in heavy compute special effects workloads, I recommend looking at a cloud. Next area is actually live production. Shows that you want to produce, like say a sports or concert or something like that, and deliver live, either over the air or through a more traditional medium. And this is a customer of ours. Unfortunately, I can't share the name, but for a 2-hour sports event, with a more traditional infrastructure where you're actually capturing the signal, the track, beaming it up the satellite, and then back down, into your data center, where you're doing the production and, sort of all the closed captioning and other things that are required. That would have taken, based on the information that we have, like a $96,000 cost, to get this, show produced. That's outside, sort of whatever rights you had to pay. Moving this, sort of into the cloud with a terrestrial link, sort of a much simpler capture and, distribution system through, the internet, and then, using the tools that are available in Google Cloud can bring that cost down to only $4,000. One of the other things that is very interesting on the production side, of course, is virtual reality. It is, the latest, hottest, area in media creation and delivery. So Google has introduced a new 360-degree camera, and that is actually tightly coupled with software running in the cloud, the JUMP platform. So you can actually capture, video and then have it stitched, automatically into a 360 experience that is compatible with many of the VR platforms, out there, and this can actually happen within minutes with, very little infrastructure setup. So those are all exciting developments on the creation side, and Google Cloud brings both, just the raw compute power, if that's what you want to get, if you want to run your own custom software, plus a whole lot of, pre-configured software if you're a smaller shop that, doesn't want to develop the technology, you just want to create your content and then use existing technologies to process it. The personalization side is probably by far the most interesting development in our space. So what we think is happening there is that people don't want to consume the same thing, even if it is at the underlying show is the same content that is being delivered to them. They might want to, consume it in different ways. They might want to compress it. They might want to expand it. The producer may want to show very personalized, commercials to each person. So the personalization space is the area which is most ripe for disruption, and we have a number of exciting technologies to bring there. Some of the stuff is actually fairly straightforward. Spotify is another one of our big customers, and one of the things they do, of course, is they run these very large analytics jobs on a daily basis, or weekly basis actually, where they try to figure out how best to change their recommendations to their customer base about what it is that they should be be listening. This was a job that used to take 96 hours to run on their core cluster. They modified the processing engine using BigQuery inside Google, and of course Google's compute infrastructure brought that down to 15 minutes, which means that you can actually run it multiple times a day, with lots of what if parameters, and to try and sort of segment your population and try different strategies and see which one works best. Another area that is very exciting in Google Cloud is virtual live linear streaming. So what we mean by that is you have various VOD assets, and you want to create a personalized linear channel for your consumers. So this would have normally taken a fairly sophisticated setup, production setup. In the cloud, it becomes as simple as dragging and dropping your assets into a channel, and then streaming it over the internet to the end user. And in addition to that, you can actually customize some of those things using machine learning technology, which is the area that I'm going to go in next, about what it is that you're actually sending to any one user. So machine learning is probably the holy grail of media personalization. It is an exciting new technology. We are investing heavily inside Google in machine learning. You probably heard our TensorFlow announcements. So these are technologies. So we're investing both in the software, which is open source, but also in hardware, specialized chips that can actually run those machine learning algorithms at much higher speed than you would be able to do with traditional CPUs and GPUs. So these workloads can actually be accelerated to the point where something that would take days can actually finish in minutes. So what does machine learning apply to? Surprisingly, pretty much everything in the media workflow, in the media supply chain. So things that you might not expect, like say compression. You have a show, And with machine learning can actually automatically detect, how dynamic, the views are and adjust, sort of your transcoding so that, you would allocate more or, fewer bits or, frame rate. And this can actually help you not only produce a better video, but also a video that is cheaper, to transmit in the end. Like, would actually give the best experience at, sort of the minimum number of bits. You can use it for closed caption creation. Often for regulatory reasons, this has to be done. And, doing it manually is a very expensive process. With machine learning, you can actually do it real time on the fly. I will actually show a bit of that. And translate it to, over 100 languages at the same time. That is a great capability that, couldn't be done without it. Contextual ads, discovery recommendations, video insights. There's all these areas that machine learning can actually make easier, and the end user experience can feel much more personalized to the consumer. So what is available today? There is a number of machine learning APIs that are available already in Google Cloud. So natural language, speech, translation, vision, and video intelligence are already some of the technologies that exist and have APIs that you can use. New ones are coming online all the time. So watch this space for announcements. We expect to be very active in this space and be announcing new APIs and capabilities all the time. Here is an actually example of our vision APIs. Imagine that you have a video and you want to find all the faces or all the logos, or all the products that are actually presented as part of the organic video. This can be done automatically. And you may ask, why is this useful or important? I have a number of examples sort of coming up. Then let's take sort of the personalization story that I described earlier. Imagine a show, let's say a cooking show. And you're a consumer, and you like your favorite chef, but at the same time, you don't want to watch a 30-minute version of it. So maybe as part of a subscription, you can have that show chopped down to say 5 minutes, and have it be delivered to you with just the highlights that are relevant to what it is that you want to watch. And this can be something that machine learning can understand and deliver to you. Or in sports, let's say you're a big Patriots. I'm from Boston, so big Jets, fan, and you want to watch, the highlights of your, favorite player. You can say, I want to watch the highlights of David Edelman, from the Super Bowl, and you can get exactly that piece, delivered, to your consumption device. This is not possible today. The, toil that it would take to actually cut, sort of all those scenes a priori to be able to have them prepackaged and, delivered to the end user is just too high. So what you get is a number of prepackaged, choices, and you can select from them, but you can't make up your own. And with the power of, cloud and machine learning on media, you can actually get there. You can enhance your monetization. So you have a show, and people are actually watching in the traditional sense, and the show has a number of organic product references in it, and at the same time you're trying to deliver advertisements, because this is not a subscription delivery system. People are actually consuming it in an advertising supported manner, which is still probably the biggest chunk of how media is supported. Wouldn't it be better if you could actually figure out when a particular product is shown organically in the show, and then you could actually break and sort of add your advertisement right after that part? Contextual ads have been shown to be much more powerful than random ads shown at tactical breakpoints. So with logo detection, product detection, using machine learning, you can actually do that. You can break the video at the right point when something was mentioned. You can actually figure out what the particular consumer's interests are, and then put the right advertisement in the right place for that user. And finally, you can actually save on costs. If you think about sort of some of the regulatory requirements, Real-time closed captioning is something that we can do. Closed captioning is required because of people with special needs. So normally you would have to pay a fairly large number of people to do this, and this can happen on the fly. Accuracy is in excess of 90% at this point, more than sort of good enough for the requirements that we have. And you can automatically translate it in over 100 languages. So if you have a business that requires you to transmit to multiple countries, we can help you. So the last part that I want to talk about is all of those things actually assume that you're doing delivery of your media in a personalized manner, one-to-one. So the traditional broadcasting vehicle doesn't quite work, and you have to look at over-the-top delivery over the internet. So Google brings better economics and scale than any player in the industry in this space, and I'm going to talk a little bit about sort of how we build our network and what we bring in the delivery side. We have been at this for a long time for internal needs, and there has been a number of networking innovations both in the data center and in the wide area networking that we have published information about. So this includes things like delivery platforms like in the Google Global Cache, data center fabrics like Watchtower and Jupyter and Onyx, long haul network building blocks like B4. This is a way we build our wide distributed area network, and protocols. So we have been the driving force behind HTTP2 and QUIC and gRPC. Those are technologies that improve greatly on the experience of users, especially if the connectivity isn't that good. And we're putting them all in the public domain. We're big believers that there is no value in keeping technology proprietary. The value of a computer science company is to keep creating new technologies, not to try and keep the ones that have already been created private. So all of that stuff is actually put in the public domain, and along with many of the other things that I mentioned before, if you think like say TensorFlow or some of the machine learning APIs, all of those things we're opening up to the public, and we're saying you're welcome to come use them sort of in a packaged version that Google will give to you and will save you toil. But if you don't want to be locked in with us, they are up there for you to use and take them and wherever you want to go. So we have built probably the largest private network in the world. That gives us a number of advantages. One is that any communication inside this network is not subject to the problems that you would face on the internet as a whole. So if you're actually pushing traffic on the internet, you're subject to sort of the whims of transit providers, sort of ISPs, so on and so forth. And everybody does sort of their best job to give you the best quality that they can, but commercial relationships do interfere. And Google has actually built this network with a target of 5 nines reliability, triple redundancy, and capacity is planned on sort of every 6 months to make sure that everything that we have on the network fits. In addition to that, because this is the network that carries our traffic, and I have some information on the traffic that Google puts on the internet, pretty much anything else that comes on top of it is likely to be a rounding error. So I will say a little bit more about sort of what is covered on this traffic. So we use this network for delivering our content, and we built the network and the caching infrastructure around it, keeping media in mind. And with that in mind, we have designed our architecture and platforms, our mapping system. And we have built a very extensive evaluation framework to make sure that we keep ourselves honest. So I'm going to say a few words about those areas. So our workload, by many metrics, we're somewhere between 20 and 25% of all internet traffic. If you look at the Sandvine reports, it depends on the country. I think in the US we're closer to 20. You look at parts of Asia, and we're sort of somewhere in the high 30s, or Latin America and Africa, sort of similar market shares. Our cloud traffic is rising rapidly. Overall, our traffic is growing at greater than 50% year-over-year growth. Cloud is a little more than double that from a smaller base, of course, but it's rapidly sort of becoming a good chunk of everything they deliver. It's about 10% of the total right now. We deliver in over 130 countries, and one of the things that we had to deal with very early on is an enormous catalog size. If you look at YouTube, which is the generator of most of our traffic, the content is user-generated content. That 400 hours of content being uploaded every minute is the thing that makes the catalog immense. So the caching infrastructure that you have to build to handle that catalog requires very massive storage hierarchies distributed around the world. And this is something that we build, and this is the thing that we're actually now exposing to our cloud customers. So how did we build it? A lot of it actually is based on software, and I'll talk a little bit about sort of this software in the next few slides. But the basic idea is we deploy these racks. The racks actually are a combination of disk trays, flash trays, and CPUs like you would expect. But they're actually sized to offer the right mix of IOPS and CPU. That is appropriate for a media workload. So this is the thing that we had sort of in mind when we were building it, and we have actually kept true to that goal. One other thing that we have done to try and keep sort of the cost as low as possible, and then be able to sort of pass the savings to our internal and external customers, is automating the logistics. Deploying sort of such a large number of racks and managing all the peering agreements and repairs and turn-ups and turn-downs is a significant logistical exercise. We have automated this as much as possible. So we're actually running sort of an operation teams with a small number of tens of people for a worldwide network, and have done so for the last sort of half a dozen years. And it's a big part of not necessarily technical innovation, but logistics innovation that makes such a large content delivery network possible. So one of the most difficult things to do right when you're running such a large network is how do you decide which users get assigned to which location. It's a hard problem. Many of you in the content delivery space, have faced it. You have multiple paths to a user. Billions of users, conditions that change dynamically, from minute to minute, and demand, congestion, capacity changes, that happen real time. And if you look at our network, we have a fairly long and deep hierarchy, with sort of caches deployed deep inside ISPs, then sort of larger caches deployed at the edge of Google's network that I showed earlier, and then even larger hierarchies deeper into Google's network, going all the way back to our data centers, which host the origin for the content. So the system that we have built that actually deals with this problem has a number of interesting properties. Like we consume the usual data, like BGP and routing, latency and load, the network topology, the load reports, from every link and every machine on the network. We compute sort of the limits that exist, and then produce an optimized output that we push roughly once a minute. And here's actually where a couple of the innovations have come in. One thing that we have done is to make it safe is every single resource, there's actually those boxes are much more complicated, gets archived for the last 6 weeks. So at any point in time, if we decide that something sort of looks fishy, we can actually pick a known stable state from the past. We can go back to the previous day or the previous week and select a map from that time, push it to the world, and keep it constant while actually trying to figure out what is going on that is causing misbehavior right now. So it's a great boon for stability, and allows us to experiment much faster than we would have been able if we were only relying on the real-time production of our system. The other thing that we bring to the table is how we integrate with clients. We have 3 different mechanisms, and Some of those, will be familiar to you from other CDNs, and some of them might be, new. So one thing that we have is what we call the content mapping system. So this is a very custom integration. Very few actually clients, do that. YouTube is probably the most important one. The benefit of that one is that every single client gets mapped individually. There is no aggregation. We don't try to actually figure out which clients belong to which resolver, which client belongs to which /24, but down to a single IP. When we get the request, because of the way the YouTube application is structured, you actually fetch a small piece of content that is unrelated to the actual media asset. And that gives us the information about who the client is, and then we can get the bulk of the video delivered from the optimal location for that client, given the constraints of that point in time. And we will actually remap the client over the course of a video if we decide that okay, for the first 3 minutes this was the best place, and then we had to move them somewhere else. The benefit of this is actually that because YouTube is such a big chunk of what we deliver, moving YouTube around, with this integration makes life better for everybody else as well. So, if you had a link that, would have been congested because, YouTube was putting a terabit of traffic on it, taking, 500 gigabits and moving it somewhere else, all of a sudden, frees up a whole lot of capacity for, the other assets that Google has. DNS integration is the more traditional solution that you've seen with other content delivery networks. Basic idea is clients sit behind resolvers. You actually build logic to figure out which clients are behind which resolver, and then you try to pick a location for that resolver when you get a DNS request and resolve it to the right cache. All the clients behind that resolver will go to that cache. The downside, of course, is that the association between clients and resolvers is not perfect, and sometimes you get mismappings for some subset of those clients. The last part, which is leverages heavily the private network that Google has, is what we call Anycast integration. So for our CDN customers and our load balancing customers, we give them a single IP address around the world. So we advertise that IP address from all the corners of Google's private network, and attract traffic to the closest cache on that network. So this gets you, to a very short distance from the client, because our network spans the globe. We expect only a couple of hops between the internet and before you hit the private network, and then you're terminated at one of our caches. Now that alone would have had the problem of Anycast flapping. So because you use BGP to get the traffic attracted to a particular location, BGP is not 100% stable. Sometimes, most of the times, it'll take you to the same place, occasionally take you to another place. If you're in the middle of a session and the routing protocol decides to send you to another cache, if you don't do anything clever, it will simply close the connections because it says, I have no idea what you're talking about. So what we do is, when packets come into Google's network, we capture every packet through a technology that we call maglev. It was published in last year's SIGCOMM. And we inspect every packet and then forward it to the right cache. So most of the time, it just goes to the local cache, the one that the packet just came through. But if for whatever reason BGP decided to route somewhere else, then that packet inspector determines that and decides that, oh, you came in the wrong place. I should forward you to what the right place is where your connection has started. And this is the technology that we use for the vast majority of our cloud customers. It has some additional benefits for media customers. Oftentimes, they want to strike partnerships with ISPs to get special consideration for their content. So you probably have heard the Facebook in the Facebook deals in emerging markets, or Spotify with ISPs in Europe and Asia, where they want to make your media consumption part of your, say, cellular bill. And ISPs, the way they usually deal with that is they want to whitelist IP addresses. So if you're using a standard CDN delivery framework, well, you can't guarantee which IPs are going to be used, or at least it's very difficult to limit it to a small number. Here, there's only one IP worldwide. You can give it to your partner. They will love you for it. It makes configuration much easier. So on the evaluation side, we run a very large number of systems that tells us how we're doing. So I'll enumerate a little bit. So obviously we have our simulator that tells us what we think the quality should be for every mapping change that we do. We verify that one against sort of the real systems that collect information. We have server-side quality of experience as reported by the servers that are sending video and non-video assets to the world, and we record all the usual statistics like RTT, packet loss, throughput, goodput. We have the client-side view that report metrics that are specific to the application. So if it is a latency sensitive application, we usually talk about query response time. If it is video, we look at things like mean time between rebuffers, and startup latency, and number of transitions between bit rates, optimality, and so on and so forth. So these are views that we actually expose. The one on the left is something that we expose both to ISPs and consumers. So essentially, we tell you how good the quality of your video is, for your ISP. It's available, from the YouTube, website. The one on the right is available only to ISP partners. So we are partnering with more than 2,000 ISPs around the world to deliver, our assets. So for every one of those ISPs, we actually tell them of all the connections that we have, all the possible paths that we have into their network, and what the quality is of delivering content through each one of those. And so coloring here, green means that it's great, red means that something isn't going so well, yellow is somewhere in between. And we work with them. We have gone to the point where we can pinpoint the routing element that creates the problem. So then we work with our ISP partners to fix that. Sometimes it's sort of on the boundary between us and them, like we need to turn up more peering. Sometimes it is something on their side. If it's entirely on the side of, or if it is entirely on our side, obviously we'll just go ahead and fix it. And the last thing that I want to say here is that we obviously trust our own internal evaluation more than anything that we can get out of a third-party evaluation. Getting billions of reports every day from our end clients is, we think, the best evaluation system that you can have about the quality of our delivery system. But we understand that an internal system doesn't strike the same confidence in other people that don't have direct access to it. They have to trust us for what it says. So we have commissioned studies with third-party measurement systems. This study is actually available on the web. It was done by Sedexis. It compares our delivery system for SSL delivery across all CDNs. Here I'm actually listing just a comparison between Google and CloudFront. We consider CloudFront probably our biggest competitor in the cloud space. And we prefer to compare ourselves with cloud providers that have a more holistic solution rather than just CDN providers. However, the report has all the other CDNs as well, so you're welcome to go read it. I guess what I have to say is that at least sort of in this particular measurement, it shows that our SSL delivery is the highest performing, best uptime, best throughput, lowest latency in the market. And I think with that, I'm going to stop here and leave about 10 minutes for questions. Yes, sir.
First of all, thank you. As a Google Cloud client, I appreciate your great service. I'm curious if you have an idea of when your data centers in places like South America or Australia, et cetera, may be launching.
So actually, I did have a slide on this one. So the green ones are the ones that have already launched. So right now you see that Oregon, Iowa, East Coast, which is South Carolina / Virginia, Brussels, Taipei, and Tokyo have already launched. And the blue ones are the ones that are actually expected to come online. The blue ones we expect to come online mostly in 2017. So between now and the end of the year. If you have a particular one that you're interested in and you want a more exact date, I'll have to get your card and get you information about that.
Thank you.
Yes, sir.
Can you talk about Google's expanding role in providing security at the edge?
Google's role about providing security at the edge. Yes, there is actually a number of things that you have to do to provide security. So Security, first of all, means securing the communication between end users and the delivery system, and then securing customers' assets so that they can't be compromised. So security between end users and so the delivery system is SSL. That is the standard worldwide. We have actually moved all of our assets to SSL, and one of the things that we do for our delivery system is SSL is no extra charge. Most places will actually say that HTTP and HTTPS delivery are charged sort of at different rates. At Google we decided that this is nonsensical, and as a matter of fact we want to discourage people from sticking with HTTP. We think that SSL is the future, and everybody should move that way. Now, customers' assets, there is a number of technologies there. There is things that we actually are doing internally. So, for instance, signing oracles, which will actually host the customers' credentials that can be separated, from the actual serving infrastructure. And by separating them, then you can take something that is fairly small and self-contained and protect it better. And then we're also looking at new technologies coming out from vendors. One with particular promise is Intel SGX, with enclaves and attestation. It allows you to essentially run a binary in an extremely hostile environment in a way that keeps everything safe. In an extreme case, it actually makes it possible for someone to give us a secret in a way that even we ourselves won't have access to it. Yes, sir?
You mentioned 5,000 cache points. How do those differ from the 100 plus points of presence?
Yes. So as I said, we have a 3-layer system, one that lives outside of Google's global network, one that lives on the edge of Google's global network, and then even larger that lives sort of more on the interior. The 5,000 includes the external locations. So the external locations right now are available only through custom integration. So of course, all of Google's properties are using them. Of our cloud customers, only a couple are using it because the integration is much more onerous and requires that you work with us. It's not just a few clicks on the console. The 100 locations that are living on the edge of Google's network, there is no custom integration. It is a full GA product that you can just go into the Pantheon console of Google Cloud and configure yourself.
Are those generally in co-location data centers?
The ones that are outside of Google's network are actually located deep inside ISP networks. The ones that are inside Google's networks are a combination of Google-owned facilities and co-location data centers. Yes, sir?
Hi, someone asked about security. Many CDNs are offering security services, WAF, DDoS, etc. So is that in plans for Google?
I'm sorry, you have to speak a little bit louder. I didn't quite hear you.
On security, someone asked about security. Many CDNs are offering security services like WAF, DDoS, etc. Is that in the plans for Google also?
Yes. So on security, the question is whether many CDNs are offering security services like DDoS, WAP, and whether Google is planning to offer that. The answer is yes. DDoS is actually already automatic. If you look at the way that our system works, if your assets are actually living inside Google Cloud, because it is a private network that connects our edge caches to the origin servers living inside cloud, the origin servers are never exposed to the internet. So the communication happens over private IP addresses, over a private network. It is not exposed to the internet. DDoS just can't happen. Unless somebody manages to DDoS Google as a whole, but that seems highly unlikely. Then on the issue of application security, there is actually products coming out of Google Cloud, what we call Web Application Firewall and Cloud Shield. Some of those have already been announced. I recommend go look at for Cloud Shield in cloud.google.com. You'll find more information and expect more announcements to be coming over time. Yes, sir.
I noticed a press release between Google and Fastly about Google Cloud and how it's starting to use Fastly compute. Can you explain how Google's going to relate to content distribution networks and the impact of
Absolutely. So we actually have a number of partners. It's not just Fastly. If you look at our partnerships, they include Limelight, Verizon, Akamai, Level 3. I'm sure there's others that I'm probably forgetting right now. I think this actually goes with Google's strategy of being an open environment. The assumption is that you should compete based on the merits of your product rather than try to lock in people. And each one of those partners brings their own unique strengths. Fastly is famous for its super fast configuration and purge capabilities, right? That right now are best in the industry. If that is of critical importance, to your development paradigm, then you should be able to use the thing that makes sense for you, rather than being locked in to the Google offering or to sort of another partner's offering. The expectation that I have is that our customers will shop around and will pick what makes most sense for them, and we're very happy with that. We are building this capability not only for the cloud customers, but also for our internal use. As a matter of fact, if you look at the usage pattern, internal use is still 90+% of the traffic on this network, so it's not going away anytime soon. Next. Yes, sir.
So if I use Google Cloud Platform as a customer, then does that mean that my traffic will be delivered the same way like your internal services like YouTube? So if I have a video traffic in your cloud platform, then my traffic will be moving like YouTube traffic.
So the question is, if you use Google Cloud Platform, will your traffic be delivered the same way as internal Google traffic? The answer is absolutely yes, exactly the same way. Yes, sir.
Do you have a direct connect service so that if I want to co-locate contribution fee technology in the cloud, that I can do that?
Do we have a direct connect service so that people can actually connect their on-prem production system to Google? We actually have 3 of them. There is what I would call a peering service. So if you run your own ASN, then you just go to peering.google.com, do a few clicks, and then we can actually peer just like we would with any ISP. But probably what you're asking is more the case. I have sort of my on-prem data center. I'm not an ISP. I want to connect to Google, and I want to pretend as if Google's network is my own private network. We announced that actually in March as a product. We call it Google Cloud Interconnect. It's actually something that my team works on, so I personally supervise. We provide private IP connectivity between on-prem and cloud. It is in alpha right now, so if you're interested, please give me your information, and we can talk about how you can go set up your circuits. Next. Okay, with no minutes to spare. Oh, one more.
So you said earlier that you do all your delivery using Anycast.
Correct. Well, no. We do our cloud CDN delivery using Anycast. Internal integration is using what I call the CMS system that actually goes down to the single user mapping system.
Okay. So with CMS, you get delivery over unicast, but you have that probe that needs to fire.
You need an integration with the client. That essentially we're using one level of indirection because, especially for the YouTube app, but some of the other apps, you usually don't fetch the media asset directly. You fetch something else, and then we can get information about your IP and then decide to send your subsequent requests to the right location.
So my original question was, with the solution you described earlier with maglev, detecting if a packet comes in to a different point of presence than intended, you do end up backhauling all that delivery as a result when that happens, right? On your backbone?
Yes and no. So the question is, with maglev, if something goes into the wrong place and we decide to forward it somewhere else, what happens? The incoming path will actually do exactly what you said, which is come into the wrong place, and then we use our own internal network to route it to the right location. But the egress will actually, sort of exit from what we consider the optimal location. We don't actually have to, be symmetric on the egress side. Okay, thank you so much.